In this video, we're going to be taking a look at writing inequalities. And you'll need to get out your Go Math book, turn to page 319, get out your math journal, and a pencil. Now, the essential question we'll be looking at today is how can you use inequalities to represent real-world constraints or conditions? So let's take a look at using inequalities to describe quantities. So you can use inequality symbols with variables to describe quantities that can have many values. You can see the symbols on page 319 and what they mean. So first symbol, less than, word phrases could be fewer than or below. The next symbol is greater than, means more than or above. Now, ones that might not be familiar with you, we can see it's the less than symbol with a line underneath it. That means is less than or equal to. Some word phrases, at most or no more than. The next one, greater than symbol with a line underneath it, means is greater than or equal to. Word phrases, at least or no less than. So let's take a look at letter A, and we'll do this together. It says the lowest temperature ever recorded in Florida was -2 degrees Fahrenheit. Graph this temperature on the number line. You can see -2 degrees Fahrenheit on the number line would represent where -2 is. So the temperatures 0 degrees, 3 degrees, 6, 5 degrees, and -1 degree Fahrenheit have also been recorded in Florida. Graph these temperatures on the number line. So we'll do 0, then we'll do 3, and then 6, and then 5, then -1. Okay, so those are all the temperatures that we're dealing with this problem here. It says, now how do the temperatures in B compare to -2? And then also, how can you see this relationship on the number line? Okay, so let's take a look at B, and how do they relate to -2? Okay, so all those temperatures from B there. And what we can see here with letter C, I want you to write this down, they are all greater than -2. So we can see every temperature is to the right of the number line from -2. All the temperatures are located to the right of -2. So I want you to write that down for C. Pretty obvious there. Now the next one, how many other numbers have the same relationship to -2 as temperatures in B? Okay, so in other words, what they're asking is how many other numbers have or are greater than -2. Now we could be here from now until who knows when, so infinitely many, any number greater than -2. Okay, so some example answers 1, 2, 8, 5, 10, 15 billion, all greater than -2. There's not an end to it at all. Now suppose you could graph all of the possible answers to D on a number line. What would the graph look like? So what we can see here, what we have is array extending to the right of -2, but not including -2. Okay, so that's what the graph would look like if we were to graph all the answers from letter D. Now we're going to take a look at this inequality. It says let X represent all the possible answers to D. And we want to complete this inequality. X, is it greater than, less than, equal to, less than or equal to, greater than or equal to -2? And we can see since all of those numbers are greater than -2, we can just have X is greater than -2. Now just a little tip on the greater than or less than side. Just remember the alligator's mouth is always open towards the greater number. If you can't figure out which one's less than, which one's greater than, remember the alligator's mouth, pretend this is an alligator, is always open towards the greater number. Now we're going to take a look at graphing the solutions of an inequality. And a solution of an inequality that contains a variable is any value of the variable that makes the inequality true. For example, 7 is a solution of X is greater than -2. And why is that? Because 7 is greater than -2. That would make it a true statement. So let's take a look at example 1. It says graph the solutions of each inequality and then check the solutions. So we have Y is less than or equal to negative 3. So in order to do this, we're going to draw a solid circle at negative 3 to show that negative 3 is part of the solution. And then why is it part of the solution? Because it's less than or equal to negative 3. That line underneath it shows that negative 3 will be a solution. So we can draw that dark circle. And then for step 2, we want to shade the number line to the left of negative 3 to show that the numbers less than negative 3 are also solutions. Okay, so not only is negative 3 a solution, but also any number to the left of negative 3 is a solution. Why is any number to the left of negative 3 a solution? Because the inequality is y is less than or equal to negative 3. We're going to check the solution now. I'm going to choose a number that is on the shaded section of the number line, such as negative 4. We can substitute negative 4 for y. Negative 4 we know is less than or equal to negative 3. So we know that is a solution. Obviously, it's less than negative 3. Why is it less than negative 3? Remember, it's to the left of negative 3 on the number line. Now let's take a look at letter B. It says draw an empty circle at 1 to show that we're taking a look at 1 is less than m. Now, what we need to do first of all is draw an empty circle to show that 1 is not a solution. Remember, an open circle for inequalities that uses greater than or less than symbols, and a solid circle for any inequalities that are greater than or equal to or less than or equal to. Okay, so remember, without a line, we're not going to shade in that circle. Now it says shade the number to the number line to the right of 1 to show that numbers greater than 1 are solutions. Okay, so we can see circling, open circle for 1, and to the right of the 1 are solutions. So we can also check. We can substitute 2, for example, for m, and we know that 1 is less than 2. Now let's take a look at the reflect question. It says, Inez says you can rewrite 1 is less than m as m is greater than 1. Do you agree? And we'll write this out. Yes, we know the two inequalities have the same solution. So no matter what, we know that m is greater than 1 with these inequalities. So let's take a look at analyzing the relationship for x is less than 5. How is it different from x is equal to or less than 5? So we can just hear it even the way we say it, but we can see for x less than 5, x is not a solution, and it would not be included in the graph. In other words, you would have an open circle where 5 would be. For x is less than or equal to 5, 5 would also be a solution, and it would be included in the graph, okay, because the variable is either less than or equal to 5. So therefore 5 would be included. Let's take a look at number 3 on page 321. We'll do this together. It says graph the solution of the inequality. We have t is less than or equal to negative 4. So what we need to do first of all is figure out, we're going to start at negative 4, and we need to figure out if that circle will be closed or open. Now, since there is a line underneath that less than, that means less than or equal to. So because of that, we're going to have a closed circle at negative 4, showing that negative 4 is also a solution. And then we will graph to the left of that negative 4. And the reason why we graph to the left of negative 4 is because it is less than negative 4. And we do end this graph with an arrow at the end. And the reason why it's an arrow at the end, because there are an infinite amount of numbers to the left of negative 4 on the number line that are less than negative 4. So now we can also test our solution as well. So we can plug in any number to the left of negative 4. So negative 6 we know is less than -4. Now let's take a look at writing inequalities on page 321. It says you can write an inequality to model the relationship between an algebraic expression and a number. You can also write inequalities to represent certain real-world situations. So let's take a look at this. For example 2, it says write an inequality that represents the phrase the sum of y and 2 is greater than 5. And then we're going to also draw a graph to represent the inequality. Now we can also see on page 319, remember those word phrases we went over? You can also take a look at those, trying to figure out which symbols you would use. So we have the sum of y and 2 is greater than 5. So we're taking a look at the sum of y and 2. We know the sum is addition. So we have y plus 2, and then we have greater than. Okay, so we have that alligator's mouth open up to y plus 2, and then we have our 5 there. Now let's take a look at graphing the solution. So for y plus 2 to have a value greater than 5, y must be a number greater than 3. Why does it need to be greater than 3? Because 3 plus 2 equals 5, so it has to be greater than 3. All right, so what we have here is we have an open circle at 3 and shade to the right of 3, because we know 3 is not the solution. Okay, but anything to the right of that 3 would be the solution there. Okay, so what we can do now is check our solution by substituting a number greater than 3, such as 4, into the original inequality. So 4 plus 2 is greater than 5. 6 is greater than 5, so we know that 4 is a solution. Now let's take a look at letter B. It says to test the temperature rating of a coat, a scientist keeps the temperature below 5 degrees Celsius. Write and graph an inequality to represent this situation. So we're going to write the inequality, and we're going to let T represent the temperature in the lab. So now we know that T is less than 5. So we know that the temperature must be less than 5. Now what we need to do is graph the inequality. And you can see you're going to start at 5. There's going to be an open circle at 5. And the reason for that is 5 would not be a solution. You can also just look at this anytime you're taking a look at just a greater than or less than symbol. You're always dealing with an open circle if you're graphing the inequality. So you'll start with an open circle and then fill in that number line to the left of 5, ending with an arrow showing that this solution can keep going to the left of 5. So now we can test our solution. So we can see 4, for example, because it's left to 5 on the number line. 4, we know, would be less than 5. Now let's take a look at number 4. It says write an inequality that represents the phrase the sum of y 1 and y is greater than or equal to 3. And check to see if y equals 1 is a solution. So what we could have here, we could have the sum of 1 and y. So since it's the sum of, it's going to be addition. 1 plus y is greater than or equal to. So we have greater than or equal to, that line underneath that, 3. And what we can see here, that would be the inequality. Now we need to figure out to check to see if 1 is a solution. So what I would do is I would plug in 1 for my variable. 1 plus 1 equals 2. Remember, the inequality is 1 plus y is greater than or equal to 3. So I know 1 would not be the solution for y. So let's take a look at numbers 5 and 6 together. It says write and graph an inequality to represent each situation. The temperature in February was at most 6 degrees Fahrenheit. So you can take a look at those word phrases on page 319, and we see at most means less than or equal to. All right, so we have t is less than or equal to 6. So that would be our inequality. Now we need to graph this. And because there's a line underneath our less than sign, meaning less than or equal to, we will close the circle for 6, and then we will draw our line to the left of 6, ending with an arrow. So you can see t is less than or equal to 6. Now let's take a look at number 6 together. Each package must weigh more than 2 ounces. So once again, taking a look at those phrases, more than, we can see it's going to be dealing with the greater than symbol. So for 6, the inequality would be, we'll do W for weight. Weight is greater than 2. So since 2 is not a solution, we will start at 2. We're going to have an open circle at 2. And then we will fill in the rest of the number line, ending with an arrow, showing that the solution can continue on much further past 12, and there's an infinite amount of solutions after 12. Now, what I would like you to do is take a look at number 1, and I want you to complete this problem, and you can work on it now. Okay, 3 and 1 would both be the solutions, and you can see that we have 1, the circle is closed at 1 because 1 is a solution, and to the right of that is filled in on the number line. So what I would like you to do now is to complete number 3. I want you to write an inequality that represents the phrase, and then also draw a graph that represents an inequality, and you can do that all by yourself, and you can work on that now. So for number 3, we have 4 plus x is greater than 6. So what we have here, we can start at number 2, and to the right of that, we can fill that in, showing that any number to the right of 2, 2 is not a solution, but any number to the right of 2 when added to 4 would be greater than 6. So let's look at the essential question check-in at the bottom of the page. It says, write an inequality to represent this situation. Nina wants to take at least $15 to the movies. How did you decide which inequality symbol to use? We have D is greater than or equal to 15. D represents the dollar amount Nina wants to take, and at least means she wants to take $15 or more than $15. So this concludes the video on writing inequalities. If you have any questions about this concept, please come and see me.